This will be just 45 minutes presentation, and we will just is a high level presentation, but somebody is interested in knowing more detail about Guinea bauxite and Indian Eastern Ghats bauxite, they can ask series of questions to me, because I am working in this area for last 45 years at most. So please, I will just request my office to start this recorded presentation. And Alex, we would also like to have your presentation on some topic on alumina. So please select your topic. As you were last time, you could not participate in IBAS. So we can keep your presentation in the month of April. So please suggest topic. Our office will contact you.
Okay. All right.
Yeah. Mr. Takuo Harato of Japan, he will be presenting the third presentation. And you can be the fourth presentation. We'll wait paper from you. Okay? Okay. So over to, I will another 2 minutes, and I will request my office to make the recorded presentation, because these are all recorded presentations. So it's easier. So you can exactly know the timings. And so it is 45, 46 minutes only. So it's not this thing. And afterwards, there will be 30 minutes for questions and answer. Okay. So welcome, everybody. I can see a lot of my friends and also common people. So everybody is welcome. Okay. Okay, so more people are joining, so it is good. So Yan Chen Wang is also there, our friend Yan Chen Wang from CRU. Okay, Vijay Pandit, okay. Okay, R.C. Patnaik. So, Alex, please think about your topic, okay? And we will contact you. Okay, Alex. Okay, so another minute, and we will start our presentation. Okay, Stuart, welcome. So it's just going to start, and is this my presentation, please? Hello. Good morning, good afternoon, good evening, ladies and gentlemen. So my today's presentation of IBAS 2023 technical lecture series is Comparative Features of India's Eastern Ghats and Guinea Bauxite Deposit. So this is what we are going to compare Indian bauxite with Guinea bauxite, particularly from the Eastern Ghats of India. So as you all know, that large Guinea bauxite mines can be compared with Eastern Ghat deposit of Odisha and Andhra Pradesh. So although geologically and geomorphologically, Guinea bauxite deposits are different from Odisha, they are all giepsitic lateritic bauxite and suitable for low temperature alumina refineries. As you all know, Guinea have 15 times more resources, about 40 billion tons, compared to about 3 billion tons concentrated in Odisha and Andhra Pradesh in India. At present, Guinea is mining and exporting about 95 million tons of bauxite all over the world. And compared to this, the Eastern Ghats of Odisha and Andhra Pradesh is producing only, particularly Odisha, because there is no mining going on in Andhra Pradesh, of 18 million ton per annum bauxite. So you can see the map where you can see the exact location of Eastern Ghats bauxite deposit. So you can see in the detailed map on the right side that all the 4 alumina refineries are shown there, so on the top, you have Vedanta Alumina Refinery. In the middle, you have Hindalco's Alumina Refinery. And in the south, you have Chutmali Mines and Nalco's Damanjodi Alumina Refinery, which is the oldest in this area. And at the bottom, you can see in the state of Andhra Pradesh and that alumina refinery. So all the major bauxite deposits of Eastern Ghats are also shown in the map here. You can see the area where your Sijimali and Kutrumali bauxite deposits are located, where you have a Pachpatmali bauxite mine, where you have Kodingamali, and all Balada and all other major mines and deposits of Eastern Ghats are shown here. So now compared to Guinea, now you can see the Guinea, which is a small country of the West Africa. And this is the area of around 37,000 square kilometer, which is almost similar to Kerala, state of India. So you can imagine the small country, Guinea, which is endowed with more than 40 billion tons of bauxite. So what are the common features between Guinea and Eastern Ghats bauxite? Both Guinea and Eastern Ghat bauxites are lateritic in origin. So they are all lateritic bauxite and occurs from the surface with thin soil cover. So it is in both the cases, there is hardly any soil cover. And bauxite starts after some laterites or ferruginous laterite, and then bauxite starts in both the places. Physically, both the bauxites looks like similar, and grade improves with decrease in iron content. If you see carefully, physically, almost it is same, although there are slight difference when you go in detail, but physically it looks similar. Chemically, also, both bauxites are free from contamination of minor oxides with low organic carbon content. So in general, the five main components of bauxite, four oxides, that is alumina, silica, titania, Fe2O3, and LOI. Together, they are 99%. So in both the cases, more than 99% is constituted by these five major oxides and LOI. And there is a simple mineralogy of both the bauxite, and they are suitable for low temperature alumina refinery, as only 1 to 3% alumina is locked up in boehmite. So this is like similar, both have the similarity. Guinea and Odisha have large open cast bauxite mines. However, there is only one old alumina refinery, that is Fria Alumina Refinery in Guinea, compared to four large plants in eastern parts of India. So you know this Africa, and Africa there is only one refinery is working. So we'll get the details in further in presentation. So you see the beautiful Eastern Ghats bauxite deposits and mines of India. On the left side, you can see the long, elongated 23-kilometer long Pachpatmali bauxite mines, which is having about 360 million tons, but left over maybe around 250 million tons. So this is a Pachpatmali, and below that you can see the famous bauxite mine of Hindalco. This is Baflimali bauxite deposit. And the right side, you can see small scale, you can see the Sijimali bauxite mine, which is just now is being auctioned, and it is of interest for everybody as it may contain around 300 million tons of bauxite potential may be there. So you can see how this disposition by satellite imageries and aerial photographs, how they look like from the satellite imageries. Now just see how the Guinea bauxite deposits. They are like octopus shape mostly. You can see the left side, all low-lying hillocks and low-lying plateaus of Guinea. And you can see some of these detailed satellite imageries of one of the famous bauxite deposit, AMC bauxite deposit on the right hand. So you can see that these are just 200 to 250 meters above MSL. compared to 1,000 meters above in Eastern Ghats bauxite. So what are the distinguishing features? So one of the important is geomorphology. Guinea bauxite occurs in series of small plateaus at elevation of around 200 to 300 meters from MSL, whereas the individual Odisha bauxite deposit is mostly confined in a large single high-level plateau, like Pachpatmali, Koningamali, Sijimali, and they are having elevation of more than 1,000 meters, and it can go up to 1,300 to 1,400 meters. The ore body of Guinea deposits run almost parallel to the topography of plateau, whereas Eastern Ghat deposits have highly undulating roof and floor that you can see because here the parent rock is chondrite, which is steeply dipping, and that's why there is a highly undulating floor in Eastern Ghats bauxite, whereas in Guinea there are more subparallel and parallel horizontal, sub-horizontal parent rocks of siltstone, and they are more or less running parallel to the topography. Strangely, in most of Guinea bauxite deposits, silica content remains low, even with low alumina. Can you imagine that 30% alumina also, the silica remains 3%, 2.5 to 3%. And this is not the case in Eastern Ghats bauxite, whereas in Odisha, silica content shoots up at the upper and lower contacts with non-ore. So this is a different story in Eastern Ghats. 8 minutes. Okay. Let us continue. Okay. Guinea bauxite. Now, what are the distinguishing features for the Guinea bauxite? Okay. That's the first thing is that Guinea bauxite, as you have told, in series of small plateaus at elevation of 200 to 300 meters from MSL, whereas individual bauxite deposit is mostly confined to large a single plateau. So this is already we have discussed, and now let us go to the next slide. And you can see these small low-lying plateaus of Guinea. So you can see the low-lying plateaus, which is about 200 to 300 meters above MSL. And you can see that these are small plateaus compared to what is occurring in Eastern Ghats of India. So they are having widespread occurrences in Guinea. Okay. And it is very easy, having very easy access, and laterite bauxite is available within 15 meters from the surface. So it's whereas in the Eastern Ghats, it may go up to 20 meter and 22 meter also. Even there is a place in Galikonda, it's up to 40 meter deep bauxite is there. Now you see typical Eastern Ghat, typical Guinea bauxite. What is the overview of Guinea bauxite? You can see in the left that they are all high alumina and low silica material. You can see the silica going down as low as 1.2, 1.3%. And then it slightly increases in the lower laterites, and in the clay, of course, it shoots up. You can see the typical mine faces and road cuttings in Guinea, where you can see the high-grade bauxite patches in light color compared to the surrounding dark color of ferruginous bauxite. So overall, the grade is much better and easy to mine, as you can see in these mine faces. And they are all 200 meter above MSL. But if you compare with this, the Eastern Ghats bauxite are high level. On the left-hand side at the lower end, you can see the famous Pachpatmali bauxite deposit. It's a beautiful 23-kilometer long plateau. And this is what is a typical high-level plateaus of Eastern Ghats look like. And you can see the right hand below how this lower boundary of the bauxite is undulating and having a lot of clay patches. So its depiction is shown at the right-hand corner, and you can see that there is a top laterite soil and laterites, ferruginous laterites, and then there is a bauxite with very much undulating roofs and floor. And this is not the case in Guinea. Guinea, it is more or less uniform. So contamination and the dilution chances are in Guinea are less compared to Eastern Ghats. Here the floor is highly undulating, and if its mining is done in the lower boundary in night time, always there is a scope of deteriorating the quality. And it is a lot of care has to be taken while mining Eastern Ghats bauxite in night time. So Guinea and EG bauxite overview. Now we see the overview. Guinea bauxite can be easily accessed and mined by surface miner or drilling blasting. Presently, Odisha bauxite are only exploited by drilling and blasting. Still, we have not started using surface miner, which is very common in Guinea, and it is more eco-friendly. So the efforts should be made in future to use surface miner in exploitation of Eastern Ghats bauxite. The normal bauxite thickness is only 8 meters in Guinea, whereas in Eastern Ghats has average thickness of 12 to 14 meters. Guinea bauxite is amenable to simple dry beneficiation process, and iron, particularly in the form of goethite, and silica as kaolinite can be partly removed by rejecting fines. So this is a very good thing, and according to our suggestion and our work, at least 2 to 3 mines of Guinea are already doing dry beneficiation of their bauxite to improve the quality. Not much beneficiation work has been done on Odisha bauxite, and it is the need now to check this high silica bauxite and high aluminous laterite, whether they respond to the dry beneficiation process or not. Guinea bauxite is slightly harder compared to Eastern Ghats bauxite. For example, Eastern Ghats bauxite have bond work index of 11 to 12 kilowatt hour per ton, whereas compared to 9 and 10 kilowatt hour of Pachmatmali bauxite. So slightly harder than the Eastern Ghats bauxite. But also there are some bauxite deposits, mines, which is comparatively softer in Guinea, particularly the Rusal mine of India. Now you can see the bauxite mining operation in Guinea. Left-hand side, you can see the bauxite mining is being carried out by drilling blasting. This is a famous CVG mine. And right side, you can see the surface miner operating in Rusal's India mine. And you can see how systematically surface miner is operated. And it sometimes works out cheaper and ecologically more preferred compared to the drilling blasting. So Guinea and EG bauxite mineralogy, how the mineralogy compares between these two main deposits. Some of the sedimentary bauxite of Guinea have fairly high bohemite content, 4 to 5%, and about 2 units of alumina locked up in the goethite. EG bauxite has low bohemite, and about 1 unit of alumina is locked up in alumogoethite. So this is the main distinguishing feature. Although sedimentary bauxite is getting over in Guinea, and now most of the leftover is lateritic bauxite deposits, where the bohemite content is not more than 2%. But there is quite high goethite content in Guinea bauxite compared to Eastern Ghats. About 50% silica is found in the form of kaolinite, reactive silica, in Guinea, compared to 80% in Eastern Ghats bauxite. Therefore, Guinea bauxite is preferred by alumina plants because of quite low reactive silica. Normal reactive silica, if 2.5% total silica is 1.2%. This is what exactly required by alumina refinery. So in Guinea, we can constantly get 1.2% reactive silica ore. So this is the beauty, and that's why the Guinea bauxite is considered one of the best in the world. As I indicated, there is a high goethite-hematite ratio in Guinea, causing settling issues in alumina plants, and consumption of specialty chemicals and flocculants increases while using Guinea bauxite. So this is one of the negative point compared to the Eastern Ghats bauxite. Some Guinea bauxite also has andalusite, slimonite, pyrophyllite, which decreases the value of ore. So there are some deposits are there in Guinea, particularly those located near the coastal belt. For example, the Alufar bauxite deposit is having significant amount of andalusite and slimonite, so which eats up part of alumina and silica, and available alumina decreases significantly compared to total alumina. Now you can see the typical chemical and mineralogical composition of Guinea bauxite. So you can see, for example, there is a 45.2% alumina. It is a general bauxite, 2.2% silica. This is very common. 2 to 2.5% silica is quite common in Guinea bauxite. You have 24% iron. You have 2% titanium. It is almost same as the Eastern Ghats bauxite. You have about 25% LOI. And available alumina is around 40%. That's the average available alumina present in most of these bauxite. Reactive silica is 1.2, just ideal reactive silica required by refinery. And organic carbon is low, 0.09%. Moisture is depending on the season. In rainy season, it goes as high as 10 to 12%, but dry season, you can get 7% moisture content. Now you see the mineralogical distribution. Mostly alumina is in the form of gibbsite. Then there is a 2.1% around bohemite, which is varied from 1 to 2% basically. And kaolinite is 0.6, alumogoethite 1.9. So very high alumina is locked up in alumogoethite because goethite content is quite high in Guinea bauxite. You can see the kaolinite is 0.7, quartz is 1.5. Of course, looks like that some of the fine grain quartz also becomes reactive at low temperature alumina refinery, and that's why the reactive silica content is 1.2%. Fe23, you can see clearly hematite and alumogoethite content is 4.5 and 19%. So it's about 4 times more. So hematite to goethite ratio is 1:4 almost. So this is what not good for alumina plant sometimes, and it causes settling issues in the refinery, and it is necessary to use specialty chemicals, and the consumption of these special chemicals also increases while using Guinea bauxite. And LOI is, as usual, locked up in gibbsite, bohemite, kaolinite, and alumogoethite. Now, compared to this thing, you please see the typical mineralogical composition of Pachmatmali bauxite. This is, of course, quite high-grade bauxite of Pachmatmali. Nowadays, you don't get to anything below 4.5% silica. So here the silica is 2.3%, 44.3 is alumina, 26 is Fe23, titanium is almost same as Guinea bauxite, and 23.24 is LOI, almost same as Guinea bauxite. But here alumina is slightly low. And here you can see the kaolinite content is quite high compared to Guinea bauxite. So gibbsite is 41.5, then 2% is kaolinite, and alumogoethite is 0.8. So here the available alumina may be in the range of 40%, 39 to 40%. So kaolinite content is quite high, 2.3%, and that's why the high reactive silica is there in this bauxite. But you see the hematite goethite ratio, which is quite comfortable. Here, hematite is more than the goethite, and that's why the Eastern Ghats bauxite are preferred from settling point of view. And then titanium is, as usual, anatase and rutile. And LOI is basically in gibbsite, kielinite, and alumogoethite. So quite simple mineralogy. And this is what quite pure bauxite doesn't have much organic content, doesn't have other minor oxides. Then Guinea and Eastern Ghats processing characteristics. So this is also interesting to know how the processing characteristics are different for these two types of bauxite. Guinea bauxite with 40 to 44% available alumina and 1.2 to 1.5% reactive silica can be considered best raw ore in the world for alumina production. So you can see 1.2% reactive silica is quite good for the plant. The main processing issues of Guinea bauxite are high goethite hematite ratio, as mentioned earlier, which causes settling issues in the refinery and require use of special settling aids and chemicals. As about 50% silica is in the form of quartz in Guinea bauxite. Sometimes this causes abrasion in pipelines in refineries, as Indian bauxite doesn't have so much of quartz content, and here the 50% is the quartz. So some refineries complains about the abrasion of their pipelines, and its life decreases, and there is a frequent breakdowns. EG bauxite, on the other hand, have 80% silica as reactive silica, and this vary from 3 to 4% in feed bauxite, causing high caustic consumption. So it increases up to 4% reactive silica. That's the problem with Eastern Ghats bauxite, and it results in high caustic consumption. Silica content shoots up in EG bauxite if proper care is not taken while mining in the floor, as we have shown that in the lower benches of Eastern Ghats bauxite, there are a lot of silica patches are there in the form of kielinized kudnalite and partially lateralized lights. You can see here the top bench is almost free from kielinite and clay minerals, and bottom bench is having a lot of white patches of clay-rich white patches. So one should be very careful while mining the lower benches in Eastern Ghats bauxite. Now, Guinea bauxite mines, there is a summary is given for all the major bauxite mines of Guinea. We will discuss out of them, we will discuss some main bauxite mines of Guinea. So, for example, CBG, which is the oldest bauxite mine, CBG is having about 8 billion tons of resources. Now, next is oldest is Kindia mine of Rusal, which is having about 200 million ton. Then there is a 700 million ton Fria deposit. GAC EGA is having 1.4 billion tons. So most of these areas and deposits are in billions of tons, whereas in India, Eastern Ghats bauxite, the maximum may be 350 or 400 million ton, and we don't have any area or deposit which is 1 billion ton in contiguous. Whereas in Guinea, you find the deposits, of course, they are in the large area, and you find a series of plateaus, and they together can be 8 billion ton, as you can see in the CBG area. So we will have short discussion on each of these mining operation. It may be interesting for audience to see how these different mines in Guinea are operating and what are their characteristics. So CBG is Guinea's oldest bauxite mine with resources of about 8 billion tons of high-grade bauxite. Its alumina is around 48 to 50%, and silica is 1.8 to 2.2%. So here the alumina is going down now, and it is expected that 47, 48% alumina can be supplied, with 2 units of alumina locked up in boehmite, and silica, reactive silica can be 1.2, 1.3%. So as you all know, there's Alcoa, Rio Tinto Alcan, DATCO, and Government of Guinea are shareholders with 49% held by the Government of Guinea. The government of Guinea also owns the, the transport infrastructure, including railway through NIM, and Sogupami has the right to market about 300,000 tons of bauxite per annum. So government is also selling small quantity of bauxite, about 300,000 tons, and rest is being sold by or exported to the plant of Rio Tinto Elcan or Alcoa, and also in Germany, Datco. So this is, as you know, this is the last 40 years these mines are working. They are well-developed mines, rails and Kamsar port infrastructure, slowly increasing the production and exporting about 22 million tons of bauxite per annum. So this is one of the biggest, but after arrival of the Chinese company, this has become second or third level. So bauxite quality, shipment size, and prices are well known by alumina refineries all over the world. Bauxite is mainly exported to North America and European alumina refineries, and occasional shipments are traded to India, China, and other countries. So mainly it is feeding the Alcoa and Rio Tinto Alcan refineries, and some of the bauxite is going to the third party. That only company in Guinea that can dry bauxite. They have a dryer at the refinery, at the port, Kamsar port, where they can bring down the moisture content to 6%. Because some of this bauxite is going to Canadian alumina refinery at a freezing temperature, and there they don't prefer more than 6% moisture. So this dryer is operating, and this is working around the year. So this is producing semi-dried bauxite. CBG's mines may run for decades or more, although high-grade bauxite of sedimentary origin are slowly depleting, and in the long run, they may have around 46 to 48% alumina, but silica will be as low as 2%, and reactive silica can be 1.2%. So they are quite well placed to having long-term export. Now another CPK, this is Compania des Bauxite de Guinea. It is owned by Rusal. This is the second oldest bauxite mine and 100% owned and operated by Rusal. Kindia bauxite is slightly different from Bouquet bauxite. It's having lower alumina content, 44-45%, higher silica, about 3%. However, this is soft bauxite, devoid of any bohemite. So this is almost zero bohemite. Annual production is about 3 million tons of bauxite, 65% of the total bauxite output earlier supplied to the Nikolaev alumina refinery in Ukraine. And now, as you know, this refinery is closed down. So the project is also in trouble at present because of Rusal doesn't have much finances, and this project may be available in the market. The high-grade bauxite resources are depleting here. However, CBK has a large license area and is exploring new deposits in their concession. Bauxite is transported by railways to Conakry, then exported from the port through maximum shipment sizes of 60,000 tons. So Conakry port is in a very bad shape, and it requires improvements. And they are planning to have the capsize vessel, but not yet capable of exporting or filling capsize vessel in Conakry. Rusal has a 25 years to operate CBK mines, and after 2026, CBK may lose their concession because government may try to auction these deposits. Now coming to the Firia bauxite mine and alumina refinery. This is also one of the oldest bauxite mine and only alumina refinery of Guinea, presently run by Rusal. So this is the oldest. You can see this was built actually in 60s by Aluminium Passionate, and And this had the old technology of atmospheric digestion, similar to our Pachpatmali mine and Damanjori alumina refinery of Nalco. The Fria bauxite mine has resources of more than 700 million ton. However, the requirement of alumina refinery is only about 1 million per annum. Fria alumina refinery was built in 1960, much before Indian plant of Nalco, Niger by Aluminium Pechne, France, and alumina is produced by atmospheric digestion process, which is now obsolete. Present plant capacity is only 400,000 tons, and Rusal is operating, I think, 200 or 250,000 tons per annum. So it's running at very low capacity at present. Aluminium Pechne had built one of the alumina plants in India, Nalco, during 80s, early 80s, based on the same technology. And the technology has since improved, and Nalco now produces 2.1 million ton per annum and expanding to 3.1 million ton alumina by adding new lines with low temperature digestion process. So atmospheric digestion is no more, will be continuing, but it is not being implemented anywhere else in the world at present. Now GAC, Guinea Alumina Corporation. This is the owned by Emirates Global Aluminium, that is EGA of Abu Dhabi. So GAC EGA now owns a former part of CBG concession, initially developed by Global Alumina and BHP Billiton to build a huge alumina refinery. But that alumina refinery had never come up, and deposits are still available, and GAC is exporting bauxite from these deposits at present. The bauxite resources of GAC deposits are in the order of 1.4 billion tons. Okay, GAC currently exports about 12 million ton bauxite per annum with 46, 45, 46, 46, 47% alumina and 2.5% silica. On our suggestion, they have started beneficiating bauxite by dry process. And that's why they are able to export slightly higher quality of bauxite. GAC has developed a multi-user port terminal and a commercial quay in Kamsar. It improved the rail network connecting the mining sites. So they are using the same CBG rail line, but it is shared with the CBG and partly with the Rusal. And GAC is at present exporting about 12 million tons of bauxite through this rail line. GAC began bauxite export to India and China in 2019 and presently expanding their mines, particularly in the southern part of the concession. And northern part of the concession is reserved for the alumina plant. But GAC EGA doesn't have any plan to set up alumina refinery in near future. They are projecting by 2028 or 29, they may set up alumina refinery, which is also uncertain. EGA has built a 2 million ton per annum alumina refinery in Abu Dhabi, which is basically based on the CBG bauxite, and they have liberty to export GAC bauxite as well as CBG bauxite from Guinea. They have long-term agreement with CBG to get their high-grade bauxite of 47, 48%. And this, as you know, this Al Wahi refinery of EGA, it is working at high temperature utilization, and they are able to extract whatever alumina locked up in goethite also, and also have easy in settling at a higher temperature because most of the goethite converts into hematite at 240 degrees centigrade, and they don't have any problem in settling of these bauxite. Whereas when this bauxite is used in low temperature refinery, there's a settling issues crops up because its goethite remains as such, and it causes issues in the settling in that plant. Now, SMB. So this is one of the company which has come up It's a Chinese company, Société Minière de Bauxite. It is formed in 2014 only, just 8 years back. The SMB winning consortium has completely changed the landscape of bauxite mining in Guinea. SMB has developed 3 large river jetties and today exports more than 35 million tons of bauxite per annum. Can you imagine the small country and they are exporting 35 to 40 million tons of bauxite? SMB started with low-grade bauxite and now export 45-46% alumina and less than 2% silica bauxite at the lowest production, transportation, and freight cost. Now recently they have acquired some high-grade bauxite deposits of Guinea also, like some Hauda. Thanks to economics of scale and the use of large capsize vessel, it is estimated that their FOB bauxite cost may not exceed $12 per ton. Can you imagine? They are loading in the big vessels of 200,000, 300,000 tons, and their FOB cost is hardly $12. SMB mainly supplies bauxite to Weichao, to their own refineries, and also to third-party alumina refineries in China. So SMB is expanding and they have acquired most of the bauxite deposits of Guinea. And they are one of the largest suppliers. There are also 2, 3 more Chinese companies are there, and they are all at 4 million, 5 million tons, and not like SMB, which is exporting 35 million tons. Now, Chalco has also set up their shop. They had gone to Guinea at 2015-16 and built bauxite mining at port operation in Bofa area after taking over mining licenses, which was formerly developed by BHP Billiton in Bofa area. Chalco started bauxite mining in 2018 and presently exporting about 12 million tons to their own refineries in China. Chalco is also using large capsize vessel of more than 200,000 tons, cheaper vessel, and exporting fairly medium quality bauxite, having alumina 44-45% and silica is as usual less than 2%. Its large river jetty is located near the bauxite mines, so the FOB cost of bauxite must be less than $14-15 per ton. So they have made a very good infrastructure there and continuously exporting bauxite to their own refinery in China. Now there are some local company has come up, that AGB2A, Association Guinea de Bauxite, de Alumina and Aluminium. So AGB2A, a Guinea-based company, produces one of the best metallurgical grade bauxite of 46 to 48% alumina and less than 3% silica by dry beneficiation process, which was developed by us only, involving crushing and screening of ore after crushing the bauxite to particular size and screening of the fines. In the process of beneficiation, about 50% high silica fines are generated, and thus mining cost of this bauxite is quite high compared to other operations. AGB2A had started bauxite export from its Kokaya port that is located near Bofa with an agreement to extract minerals from the nearby concession of GBT and Axis Minerals. The Axis Minerals, by the way, is being held by Pankaj Oswal of Indian origin, and this deposit is also now being developed and supplying ore to the AGB2A. However, operation is of AGB2A closed at present due to some administrative issues and problem. You can see how the crushing screening system is going on in this deposit and see the quality of fines and lumps being produced in this mine. Now, suggestions, development of EG bauxite. There are some general suggestions out there. Our observation shows that the third-party sale of bauxite can be challenging for alumina industry of Eastern Ghats, as each plant have specific processing parameters and changing quality harms the productivity. So this is our observation basically for Eastern Ghats, for Odisha, particularly for Odisha bauxite mines and alumina refinery. Captive bauxite mine for each refinery not only helps in improving production and productivity, also conserve valuable resources. So government of India should think at least for each alumina refinery to auction or give them preference for alumina, for captive bauxite mine. And another suggestion is that use natural cutoff values of alumina and silica to demarcate the ore body in Eastern Ghats deposit. Natural cutoff means where suddenly silica content shoots up or alumina content suddenly goes down. Particularly in Eastern Ghats bauxite, at the lower boundary, suddenly silica shoots up, and that's the natural boundary of the of bauxite deposit. Efforts should be made to use all the overburdens, aluminous laterite and high silica bauxite, and by after some dry beneficiation and series of beneficiation process, because as such there is a limited bauxite available in India, and the efforts should be made to upgrade whatever available in the Eastern Ghats box deposits and other areas also. In order to increase the reserves in mine and conserve resources, bauxite quality for refineries should be reviewed and defined every year. So this should be exercise should be taken up by all the captive mines as well as the bauxite, third-party bauxite cell. They should review the quality every year and declare the particular quality so that refinery takes proper care to use lower grade bauxite because as the life of mine goes on, quality deteriorates. As you have seen in case of Nalco also, initially they were getting 2 to 3% silica, and now the silica has shot up to 4 to 5%. And this is the case in most of the Eastern Ghats bauxite. You have to have a short-term and long-term mine plan where you can supply the exact quality of bauxite, keeping in view the resources available in the deposit and mine. So are some of the suggestion, and also some Brazilian bauxite mines are using solar drying system so to bring down the moisture content, and the test trials should be also conducted in India to decrease the moisture content from Indian bauxite so that alumina refinery does not get extra non-technological water. So now coming to the conclusion. So Guinea is, as you know, is endowed with huge bauxite resources and offers good opportunity for export of quality bauxite and set up alumina refinery. So there is a good scope to set up alumina plant in Guinea as land and water is quite cheap and there are environmental legislation is also a bit relaxed there. And Guinea is welcoming any company who can set up alumina refinery in their country, and they can allot the bauxite deposit to company interested in alumina plant. A systematic development of Eastern Ghats bauxite offer an opportunity to produce 40 to 50 million tons of bauxite per annum compared to 90 million tons of Guinea. So there is now process has started for auctioning of large bauxite deposit like CG Mali, medium-sized deposit like Kutrumali and Balada, and small deposit like Balada and Karla Part. So this process should continue and which will feed the bauxite to the existing alumina refinery. And there may be scope to set up one more large alumina plant in Odisha by using the local bauxite. Going forward, it will be necessary to use all the overburdens, aluminous laterite and high silica bauxite of Eastern Ghats deposits of Odisha and Odisha by adopting suitable beneficiation process. So all these materials should be used which is having more than 35% alumina. Anything more than 35% alumina can be beneficiated by dry process, and this material should be used in the refinery. And it is a suggestion again, a grade control drilling, systematic quality control system, and short and long-term mine plan can reduce day-to-day fluctuation of bauxite quality supplied to alumina refinery. As you know, the day-to-day fluctuation in quality deteriorates the productivity of alumina plants, and it causes a lot of harm to alumina refineries, and caustic consumption increases, and digestion efficiency also suffers. So thank you very much for your kind attention, and we are now open for any questions on Guinea bauxite and Eastern Ghats bauxite. Thank you very much, and the session is open for this.
I can't hear you.
Sorry. Yeah, no, it's my mistake. Okay, so you are all welcome. You can ask any questions on Eastern Ghats bauxite or Guinea bauxite, whatever your interest. It's the general presentation, and for details, you can always contact us. So please, is open for questions and answers. Alex, Stuart, any questions?
Well, I have had some experience with CDG bauxite, and yeah, I think your presentation was really spot on some of the characteristics of the bauxite. My experience in the Abu Dhabi refinery was the major problem there. They use very high temperature, 270 degrees digestion temperature. So very, very high temperature. So yes, they don't have the settling issues that maybe the low temperature refineries have. Settling was not a problem at all. The major problem though was iron in the liquor, which contaminated the product. So that was the major issue. The iron is low, and due to the high digestion temperature, they tend to get around 20 milligram or more in the liquor after digestion. And because there isn't a large iron surface area in the slurry, it doesn't precipitate during the digestion and settling phases. So by the time the pregnant liquor is going to precipes, it's still got significant amount of iron in it, and all kinds of attempts are made to reduce it with injecting lime into digestion, but it's a bit of an art than science, so it doesn't always work, and they tend to still have quite high iron in the pregnant liquor, which contaminates the product. So yes, in the high temperature plants, the challenges are a bit different compared to the low temperature plants.
Very good observation. Excellent. We were thinking that you have all the advantages at high temperature plant, but now we see that the iron behaves differently at high temperature plants, and you have another issue of iron contamination in the product. So very interesting observation. And so what do you suggest? What should be the optimum digestion parameter for CBG bauxite?
Well, I guess it all depends on the cost of the bauxite to the refinery. So for EGA, obviously the cost of the bauxite is one of the highest costs, because they have to freight it over such a long distance to the refinery. It makes the bauxite very expensive. And therefore, the economic decision they've taken is to extract as much of the alumina as possible. So they are aiming to get all the bauxite as well as some of the aluminous goethite out of it. And well, whilst that helps you with the extraction, the alumina extraction, it has its other problems, like I've mentioned. And the problem is, sure, with the high temperature, some of the iron tend to go into solution. And with the relatively lower iron in the slurry, it doesn't have enough surface area to precipitate it. So it contaminates the product. So yeah, with all of these things, you can't have it all. Either you're extracting all the alumina, or you can go to lower temperatures and sacrifice some of the alumina, and maybe the iron problem might go away. But this is not something they've really trialed. They've been operating all the time I was there. They were operating at 270 degrees. So yeah, we don't know whether lowering the digestion temperature will help with the iron problem. But yeah, they are trying different things. And like I said, lime injection is the one they've trialed, and sometimes it works, sometimes it doesn't. And it's something that they are still studying to understand how to make it work better.
Okay, very interesting, quite interesting observation, and that's we will include this interesting observation. Thank you very much, Alex, for highlighting this point. And I think a blending of 2-3 types of bauxite may help them. If there is a bauxite with a low iron content, 8%, 10%, that may help them. So let us see how they have to blend bauxite with other quality, maybe. Maybe I'm not sure how this problem can be resolved.
Yeah, I think you may not be wrong there, and I think that is a thought they have had also, which they are planning to trial at some point. But yeah, it's been a year since I was last there, so I don't know how far they've come in these trials.
Excellent, very good. Thanks, Alex. Any more question or observation, please? Takuo?
Hi, I have one question about Alex. And you mentioned that in EGA, in Abu Dhabi, you experienced high iron content in the pregnant liquor, so resulted alumina contamination. And you mentioned that mixing bauxite with different grade, is it to solve the problem?
Okay, so like I said, the idea of mixing different bauxites with different iron content is a suggestion that has been mooted. And I actually did some test work in the lab, but this has not been trialed in the plant. So it is a project that they plan to do, but obviously this requires a fair bit of logistics to get, one, the right mixture of different bauxites to ensure that the iron content will be the right one. So it requires a fair bit of lab work. And once this mixture has been, identified or specified, then it's a question of logistically getting the shipments into the refinery, blending it, and doing a trial. So it's quite a massive exercise in itself. Whilst I was there, this was still in the lab stage. The testing were in the lab stage. And like I said, I haven't been there since a year and a bit ago. So I don't know how far they've come in implementing some of these suggestions. But by the time I was leaving, the only thing they were doing was the lime injection. into digestion, which I said sometimes worked, but sometimes it didn't.
Mhm.
Thank you very much. And another question is, Ashok, you mentioned that FOB price in Guinea is $12 to $15 per tonnage. And how about the CIF cost when it arrives to Abu Dhabi or somewhere? Freight
No,
cost.
this is what I told, $12 to $15. This is the cost of the company. But
Yes,
actual FOB,
FOB.
when they charge, Guinea government has now new legislation. They cannot export bauxite below the international prices because they have to get the taxes and everything. So at present, the bauxite prices in Guinea is going on around $40, $35 to $40 FOB. So that's the minimum price they can sell it. They can produce at very low price, so they can earn profit in the country, but they have to pay taxes on the profit. So normally when it reaches to alumina refinery, for example, Abu Dhabi, I'm not sure today's rate, if they're reaching, it must be $55 or $60 per ton. What do you think, Alex? It must be in that range. Capsize vessels. Taku. Yeah. $60.
$60. Thank you.
Minimum.
Minimum $60.
At the refinery.
Then easy bauxite must have some advantage or something when you export.
No, EG bauxite we are not exporting. India is not exporting any bauxite now. This is the bauxite we are talking about Guinea. Only Guinea is exported. India has no scope for exporting bauxite. We have our own consumption now. And the new alumina plant and consumption, because India is importing bauxite.
Yes. Thank you.
Any more questions? Anybody wants to know anything more, or they can always correspond with us also, but any question we can answer. See the Yanchen Wang also in the conference. Okay. Yanchen, are you in the line?
Hello, Ashok.
How are you,
First,
Yanchen?
I'm good. Thank you. First, it's a very good presentation. Thank you very much. Very lots of information. Thank you very much. I think I have another topic would like to ask. What do you think in 2023 June, the Indonesia government will ban the bauxite export? In their plan, they will ban. So what do you think of the bauxite market in the future?
Yeah, that's a good question. Indonesia is partly or almost closed their export. There are opportunities. Guinea has now almost full of 100, not more than 100 million tons can be exported from there. It's a small country, infrastructure. So this is the peak Guinea can export. And I know that demand in China is increasing. And I think present demand is going around 150 million tons, no, in China?
Yeah, in China, as more and more refineries, especially some greenfield refineries, they are using imported bauxite. They have been built in the coast area, east coast part of China.
Yes.
And they rely on imported bauxite. But the majority definitely is from Guinea and Australian. But Indonesia normally is the third largest bauxite supply to China. Correct. If they ban the bauxite export in June, definitely it will affect some refineries in China. I think that will push the international bauxite price even go up. Yeah.
Correct. Australia can partly fulfill, but Australian bauxite have its own limitation. Maybe low temperature alumina refinery bauxite can fulfill, and high temperature refinery, as you know, that WAPA and Doom deposits can fulfill. But I am not seeing any other places, because Sierra Leone also had a problem now with the bauxite export. Ghana may come up. So Alex is actually from Ghana, but it's going very slow. But he was my colleague in BHP Bulletin, and he is stationed in Australia, not in Ghana.
Yeah, agree. I think the other suppliers is quite small in terms of scale. So yeah, they can't fully replace Indonesia bauxite. I think the bauxite still will rely on the Guinea and Australian in the future. Yes.
Yeah, Guinea is, but there is a limitation in Guinea. You cannot go with 120, 130 million ton because it's already infrastructure is crumbling. There's more than 100 million tons, I doubt. And Guinea government is very much insisting for the alumina refinery. And then every discussion, every talk, they are telling that if you want to develop bauxite mine, you have to make alumina refinery here. And SMB and Chalco, as well as GAC, they are all under pressure from government of Guinea. They say that you should set up alumina refinery. So let us see how it develops. But there are issues in Guinea because apart from bauxite, there is nothing in that country, neither energy nor caustic soda, nothing is there. Only bauxite is available.
Yeah, that's correct. There's lots of challenges there.
Yes. Okay, I understand. Malaysia is going to start bauxite export, or no? They are also having issues at present. Yanchen, Wang.
I think Malaysia, they may export some if the price going well, but the quantity and the quality is not very good, as
Not
you
very
know.
Yes.
Yeah, and so I think some small Chinese refineries may purchase some bauxite from them, but in China, aluminum capacity is quite a huge number, and they are over capacity. So I think the market need to force some inland refineries to shut down their production line in terms to supporting the aluminum price. And so lots of challenges in Chinese aluminum and bauxite industry currently. Domestic bauxite, the quality is not going well, and so the cost is really high as well. So
I understand. We understand. Yeah, this is that's why the prices of bauxites are increasing, because now it is going higher than $40 FOB, almost $40. Yes.
Yeah.
So friends, any more question? And presentation will be available on website of IBAS. And Wang, if you want some time, please make some presentation on Chinese alumina refinery in this forum. We'll request you to, we will send you mail, and if you can agree, please, and IBAS will provide you forum for presenting demand in China. And Alex, okay, so can you please?
Yes, just we can talk about that by email. Yeah.
Okay, sure. Yanchen, we'll write to you.
Mr. Nandi, I have one question.
Please, Shankar.
Do you foresee any more alumina refinery project coming up in the next 2 or 3 years in India?
Yes, there is quite a good scope. I'm not sure which company you represent, but Adani is very serious to set up greenfield alumina refinery in Odisha. And that's big deposit of CG Mali is being auctioned, and that's having more than 300 million ton. But before that, we would like to see at least Vedanta Alumina Refinery gets a proper bauxite deposit, because that's the huge alumina refinery. They have a plan to go for 4 to 5 million ton. I think the first priority, as I feel, is government of India's view may be different, but as I feel that Vedanta Alumina Refinery should get a proper bauxite deposit so that they can work. And everybody is having their own captive mines. Why not Vedanta Refinery should get their own mine? So, but there is a clear scope of one more alumina refinery in Odisha, and it may be decided in coming 4 to 6 months' time.
You think Andhra will also get the local bauxite?
Yeah, and right, but problem is with Andhra Pradesh government, they are not allowing them to mine their own bauxite. They may purchase or they may get some deposit, small deposit in Odisha only, because Andhra Pradesh deposits are not being exploited at present. And poor country, poor alumina refinery to depend completely on import of bauxite from Guinea. So that's not a very good thing when the alumina refinery is there and they don't have bauxite. They are sitting right on the bauxite deposits. But unfortunately, due to the local politics and local issues, they are not able to mine. And they are completely dependent on import. So that's the situation. Yes.
Is there a scope for NALCO expansion, further expansion?
Yeah, NALCO further expansion is going on already. NALCO is a Putangi bauxite they have got already, and they will go for expansion, but slow, but they will go. Okay, any more questions? So if no other question, thank you very much to all of you for your kind attention, and please be there. Next lecture will be by Hindalco gentleman, Dr. On bauxite only, Dr. Tathawadekar, Vilas Tathawadekar, and please see the next presentation. And after that, there will be a presentation by Japanese expert, Sumitamo expert, Tokuo Harato. He will make the third presentation, and then we will request either Alex or Yanchen Wang to make presentation in this series of lectures. So you will get a wide number of alumina specialists, because this is basically bauxite paper, and we just resumed our presentation. You can see if there is good alumina paper, there may be 100 and 120 delegates may be there, or participants may be there. So we'll request all of you to be there. Every month on the Friday, we organize between 4 to 5 p.m. Indian time. So you are all welcome. And please keep looking to IBA's website, where we are announcing this lecture series. Thank you very much. Thanks to all you all, and see you. Thank you.
Okay.
Bye.
Thank you.
Thank
Bye-bye.
you.
Bye.
Bye. Bye. Bye.
Nice. So